And we are live. Good evening, everyone. I think I got rid of that annoying horn. Let me know if that horn shows up. So we have a lot to talk about tonight. There's a lot of things to cover. A lot of things I've been looking at. First of all, I hope everyone's been enjoying or finding okay the new update structure, which so far is working out really well. My goal is to have this basically really locked in for the winter. So the goal is to have text discussions in the evening to discuss the latest model guidance coming out, especially winter storms, and then video discussions in the morning to discuss new data there. And so you constantly are getting new updates, not just in the morning, but in the evening and afternoon. So I think that's going to work out great. And so far, so good. Also, hey, it rained. Finally. It finally rained around here, and some locations got quite a bit of rain, and other locations, well, you got some rain. And we got a lot of reports of the soil starting to improve. Now, it's just the start. We're nowhere near out of the drought conditions that we have built up because of this very dry summer. But certainly an improvement, and we're going to discuss the changes that are starting to evolve in our weather pattern that would suggest more wet weather patterns like this are on the way. More storms like this are on the way. Very interesting stuff to study. Also, I have been studying the evolution of the volcanoes. The volcano that dropped a lot of water vapor in the atmosphere. And I've been reading a lot of studies, a lot of controversial and conflicting data on how the introduction of all that water vapor into the stratosphere, especially the upper stratosphere, and then working down, influences the 500 millibar pattern. The data, okay, and the research has two basic families. One is that the introduction of water vapor in above normal state in a normal environment leads to a cooling of the stratosphere, which leads to an expansion of the troposphere and a warm weather pattern overall. However, in cases of volcanic activity, where you're introducing water vapor into the higher levels at an exaggerated rate, it leads to more of a dynamic impact in which you get these clashes in the upper atmosphere that enhances high latitude blocking. But that only happens if the QBO in a westerly state works with the environment that starts to develop with the cold pockets and warm pockets. And of course, the other wild card is that in other events where we were able to study the water vapor introduction via volcanoes, it happened during a quiet sun period, and now we're in an active sun period, and we don't have data on an active sun period. So major wild card there, which is going to make this winter forecast very, very interesting and a lot of fun and very chaotic. So I'm going to basically work on new theories based on the research, kind of standing on the top of research from other great meteorologists and atmospheric scientists, and try to figure out my own way and own theory on how the atmosphere is going to react with all these different factors that we never really seen before, which is really exciting, but at the same time really annoying because it's going to be very difficult. And I think that some of the influences that we have seen this summer is part of the volcanic influence, i.e., the strong ridge that we saw in Europe, which enhanced the moisture transport, or should I say the dust transport off of the Sahara Desert, which has completely screwed up the forecast for the tropics, is part of that whole mechanism. And because of that mechanism, what we can learn from that with the active sun and a naturally colder stratospheric environment as a result, which here, let me show you this data here. Right here we go. This environment right here, well below normal ozone. which means rapid cooling. Okay? And that rapid cooling throughout much of the northern hemisphere, you could do the same thing for the southern hemisphere, leads to enhancement of ridges. Now you might think, okay, well that automatically means warmer atmosphere for everyone. Yes, in some cases, but it also means that you have to have a balance in the atmosphere. So when you have this environment, you also get enhanced low pressure systems and below normal heights, i.e. what we've been seeing around the Aleutians. So that's the summer influence. Now we flip it to the winter. Winter, we have more chaotic environment. We have to watch out for the snow growth in Siberia, the low sea ice environment in the Arctic, which enhances high latitude blocking. And oh, by the way, this signal out here, okay, this signal supports a trough somewhere in this ballpark right here, which leads to a trough here, which leads to our active weather pattern, wet weather pattern that we're going to be evolving into. But this environment, this signal right here, typically supports a positive NAO. Now, it certainly will through the fall. But what's going to be interesting is that the influence of the below normal sea ice, coupled with the enhanced water vapor transport in the stratosphere, based on the data that we have, typically supports a negative NAO pattern. So now we have a conflicting signal. Usually these signals work together, but this time they're not. So now we have to figure out if high latitude blocking is more supportive in the stratospheric environment combined with the volcanic influence, but the sea surface temperatures are not, what type of evolution in the 500 millibar pattern actually transpires. And I'm still working on that, but one thing that really stands out to me is that every time you get a low pressure system right around here, and we're going to see this in the tropics, which we'll talk about in a moment, the low pressure systems erupt. We have a lot of energy out there. This is a lot of potential energy. Okay, you learn in science in high school about potential and kinetic energy. This is a big old pot of potential energy that's just waiting to erupt. If you get the right blocking, you get the right interaction, you get a weakening La Nina, things get awfully interesting. Now, I'm not promising snow for everyone, but I am promising an active weather pattern, okay, based on the signals I'm seeing. Okay, so very interesting data in the long range is kind of standing out to me, and that I'm looking at it and saying, this is going to be tricky. This is going to be a tough one to split, to work up. And by the way, I'm going to answer all your questions on YouTube and everything else. Now, I got a couple email questions about this, and we'll get back to the weather pattern overall, but I wanted to cover this because I know I got a lot of requests about this, emails, stuff about stuff like that. And and we also have, of course, the climate change stuff. We also have to cover that stuff. So I'm going to just knock this right off the bat here, and let me go to my regular. I want to make this. I want to be very careful with what I'm going to say here, not because I'm worried about what somebody's going to think or cancel culture or any of that crap. It's because I care about this very much, and I want to be as honest as possible. So, if I was going to comment on this whole Jordan Peterson thing, I thought it would be appropriate to actually listen to what he had to say. Now, there's all sorts of political aspects to it, one world government, all that stuff. And I'm not going to argue about the politics involved, because as you probably all know, I'm a libertarian, so you know how I feel about that. But in terms of the science, there are some things he has right and there's some things he has wrong. And I blame this on the very factor we talked about last time when we covered the IPCC report that came out, where a lot of people rely on the upper range in terms of our output of CO2, and that focus to me has always been a mistake. It has always put me at odds with some other meteorologists and scientists out there on Twitter and whatnot, because of how I feel that we are portraying the science. It's good to give an upper bound, okay? But to focus on it leads to this type of reaction, okay? Based on basic laws of science, basic physical laws, if you introduce something into the environment and enhance that introduction, you have to have a reaction. For every action, there is a reaction. So if you add CO2 into an environment that was in a different state, that you cannot compare the CO2 state of the Cretaceous period, which was much higher, to where we are now, because you had a different Earth axis, you had a different environment in terms of your continents, and oh, by the way, you had a completely different species involved there, and different plant life. Now, does this mean the end of the Earth? No. This doomsday stuff has always been bad for our science. I've always been against it. But at the same time, the idea that, oh, everything's fine and we can just keep on doing what we're doing is also bad. If you're into extremes, then you're into a non-solution world. If you keep a calm head and look for realistic, now remember what I said, realistic solutions, you can solve anything. Okay? So, I think Jordan Peterson makes a good point on some of the reactions and some of the solutions that some suggest. Like, for example, cutting off all fossil fuels in a very short period of time. Sure, great. And we could also all have unicorns and ponies, at the same time. And magic teddy bears, but it's not realistic. It's not realistic. I'm sorry. You're going to hurt a lot of people. And when you hurt a lot of people, then you get a fallback and people go back to old technology. Coal. Check out Europe right now. So, he's right on that aspect. But I don't believe in doomsday solutions. I don't believe in everything's fine, pie in the sky solutions, okay? We need to find better technology for a variety of reasons, like war and everything else, and just being able to take care of our people in general. All of our people, the entire earth. But stay away from absolutists. Absolutists and people who are very much into, I guess, what's the word I want to use? They have to have perfection in their ideology. That you have to follow everything in the ideology. Are dangerous, whether that's in science, politics, what have you, sports, whatever. Purists always look for perfection and always get failure. Always look for improvement, not perfection. And you can put that in anything in your life. So that's my comment on Jordan Peterson. I don't think he's a bad guy or a big boogeyman or anything else like that. He has some ideas. You can agree, you can disagree. That's fine. But in terms of the science, yes, there's climate change. In terms of the end of the world, no, the world's going to be fine. As one famous comic said, the earth is going to be fine. just got a bad case of the fleas called humans. We'll shake it right off.
You really butchered that.
That's fine. See, I'm good at butchering things, like the English language. That's why I'm learning Spanish, so I can butcher the Spanish language too. So that is my thought on all that. Now let's talk about something fun. And people always ask me these things, like as if I'm some sort of like great wealth of knowledge. You guys know where I stand. I stand for solutions, common sense, and hamburgers. I like hamburgers. So let's talk about the tropics here, and then we're going to talk about our weather pattern that's evolving. And while I'm having some coffee, thank you very much, Susan. I'm having some French vanilla coffee. Keeping me rolling. Now, the tropics here have gotten more active, which you would expect this time of year, which is great news. Well, kind of great news. Let me explain why this is great news. It's great news because it starts to transport the heat energy from the tropics into the polar regions. If you don't have that, then you start to develop a big feedback loop, and it creates a lot of havoc in the winter forecast. So the fact that we're seeing this releases energy, and it's important because then we can start to see the transports from the tropics to the polar regions at all levels of the atmosphere to get a better read on how the polar vortex is going to be evolving. So it's good in that respect. The other good thing is that so far not one of these storms is getting anywhere near the East Coast. Danielle's leaving. Let's see here. There's Danielle right there. It is starting to become more and more subtropical. Now, it was over the Gulf Stream. It's starting to lose that influence. It still has the structure of a tropical system, so you have this nice circulation here, but it's losing its structure slowly but surely and likely to become extratropical probably by tomorrow morning, if not tomorrow afternoon. And it's going to be a big threat for locations like Spain, parts of Ireland, so have fun with that, guys. Now, the next one's Earl. Earl is getting interesting. Its eyes starting to strengthen. It's starting to develop here. It recently, the National Hurricane Center put out an alert saying that we're seeing some strengthening going on with winds up to 90 miles per hour with the 8 p.m. update. Right here is Bermuda. Earl is going to pass to the east of Bermuda, but likely produce some marginal hurricane strength winds, definitely some strong tides. It has the potential of becoming a major hurricane, and in fact, that is the forecast here for it to become a major hurricane as it passes through Bermuda. There's a ton of warm water here, as we could see right here. So it's about to move into what essentially is nitroglycerin for hurricanes, and it is really going to get its act together. You can start to see it evolving here very nicely. See that shape taking place. This convection right here is about to wrap around it. So by tomorrow morning, we're likely to see a very nice, well-developed hurricane. Not much in the way of any vertical wind shear right now, but eventually, as that trough from the west, which you can see right back here, starts to approach our hurricane, it will start to tear it apart probably by tomorrow night, and it'll reach its peak maximum strength and then exit out. So the good news here is that it won't hit any land. Another interesting thing is that it's likely to enhance our 500 millibar pattern a bit and lead to some stormy conditions as you head up towards Iceland and Greenland and slow down our weather pattern just a little bit. Meanwhile, we have more activity out here in the Atlantic. This is likely going to be a tropical depression. Right now, the winds are favorable, but you see this portion right here? This is vertical wind shear setting up here. So this doesn't have a lot of life left in it. It could become a tropical depression, maybe touch a tropical storm strength before it gets turned back into the northern Atlantic and gets sheared apart. So I'm not really expecting much out of this. This one, though, this one we should watch because it's a little bit further south. It's not likely to... One second. not likely to get picked up by this trough here. And it could be a threat in about 10 to 12 days for the Lesser Antilles, and something to keep an eye on around the Bahamas. So keep an eye on this feature here. I think it's going to be a factor. And all the way out in Africa, you can see all the way back here, more tropical waves on the way. So this is pretty much par for the course for September. I mean, if we stayed quiet all through September, that would be a record quiet season and a record bust in terms of the forecast for the hurricane season. So, I mean, it's still setting up to be a bust. There's no way around that. You know, every forecast that's out there is going to get burnt to a crisp this year, which, quite frankly, as I've said on Twitter, I rather have. I mean, look, I love being right, but if it means I'd rather be wrong and have no one lose their home than be right and have multiple hurricanes hit the East Coast. I mean, money-wise, yes, I make more money. I understand that. But I'm fine with people not losing their homes. I don't need another Hurricane Sandy, thank you very much. So we got that. And then we have back home. Nice northeasterly wind. Temperatures in the 60s and 70s. No air conditioning. It's very nice. Cloudy. As you know, I am a fall and winter guy. I'm not much of a summer guy. So I'm thoroughly enjoying this weather, especially the nice light rain. This continues on through this evening and then starts to break up after midnight. But we have plenty of cloud cover here, a nice easterly wind pattern. Take a look at the low-level winds. There's our storm here. Here's our other low-pressure system off the coast with that fetch coming right from the Canadian Maritimes. You could take this all the way up to about the coastal waters of Greenland, all the way down through the Canadian Maritimes, right into our neck of the woods. Very, very comfortable, at least to me, conditions. So we have this fetch coming at the lower levels, but in the upper levels, we have our southwesterly wind. In fact, here, let me flip this data here for a second. Go to 250 millibars. And we'll start at 250. You can see the winds out here with our positively tilted trough. Now, for those of you who don't know what I mean by positively and negatively tilted troughs, positively tilted trough is when the trough axis, which you can see very nicely here, is like this. Okay, northeast to southwest. A negative trough is the exact opposite. It's a line like this. And a neutral, well, neutral is north to south. So this is pretty close to neutral. It's slightly positive. And this is positive. Don't really see a negative trough around here. It's not really a pattern that's conducive for negatively tilted troughs. But you could see this environment here. Now, in this scenario, with a Western Atlantic ridge, this can lead to a wet weather pattern. Because what happens is that with this trough aligned like this, frontal boundaries tend to stall out, which is essentially what you have here. A lot of stationary fronts, the waves of low pressure developing along it, onshore flow, moisture coming in at the mid-levels and at the lower levels from the northeast, and you get this overcast cloud cover and scattered showers. And then if you get just the right alignment with some orographic lifting and some upper level divergence, like what we had this afternoon over northeastern Pennsylvania, you can get a nice area of moderate rainfall sometimes. And of course, yesterday we had our moderate to heavy rainfall throughout the region. Now, in this environment where you have this setup take place, you can end up with a lot of stationary cold fronts, waves of low pressure, and periods of rain for a day or two, and then continued unsettled conditions with a spotty shower here and there. It also leads to prolonged periods of tranquil conditions, which is essentially what we're setting up for this weekend, because it takes a while for the trough to get here, just as much as it takes a while to get out of here, it takes that long to get here. So we end up with a couple of tranquil days starting tomorrow and continuing on through the weekend. It's going to be perfect. So if you have any outdoor plans or anything for Saturday and Sunday, guess what? Perfect weather for it. If you got, by the way, the NFL forecast that for the Giants, Jets, and Eagles is now part of the sports forecast that I've been posting every morning for the Mets, Phillies, and Yankees. Below that is the Giants, Jets, and Eagles. So definitely check that out if you have some chance. So that should be pretty much a lot of fun there. Let's see here now. Let me pull up some of the model data, and I want to show you the 500 millibar pattern. Now, the latest data that we have and the latest trends, the WPC, and I agree with this, pretty much is removing the GFS. It has the GFS ensembles guidance involved in their forecast, but the GFS is playing catch up with the European guidance, and the European guidance is basically the basis of the forecast from the National Hurricane Center, National Weather Service for the United States, and also if you use the EPS for long range data. I like that idea because basically the European guidance, especially the ensemble guidance, is handling this volatile weather pattern the best. So that's what we're going to lean on tonight. If you use the GFS, what you want to do is adjust for the very fast moving troughs. It's a little bit too fast. But if you mix in the European guidance and the European ensemble guidance, it starts to align a little bit better. And the Canadian basically agrees with the European guidance, except for a enhanced trough over northern Canada around day 10, which doesn't look like it's very well supported even by its own ensemble guidance. So we're going to lean on the GFS. I'm trying to say on the European tonight, not the GFS. And the reason why I want to use it is because of what it's showing here. What it's showing in the operational and in the ensembles is a very interesting theme that I think is going to remain in place for much of the early fall, let's say through about mid-October. And that is that we're going to continue to see this trough here bouncing between the central Aleutians and the western portions of the Gulf of Alaska. It's going to lead to a transient trough on the west coast, the immediate west coast, a ridge around the plains and the Rockies, and a positively tilted trough around the eastern United States. And that trough axis combined with our western Atlantic ridge is going to try to continue to pop, is going to lead to a scenario much like what we saw this week, where you get these stationary fronts trying to come in. You're going to see a lot of humidity, a lot of warm, low temperatures, and near to only slightly above normal high temperatures. When I say slightly above normal, we're talking about 85, 82, 83 for highs. You can say goodbye to the 90s. I think they're pretty much done outside of a rogue day here and there, which you can get during the fall. But this pattern reminds me a lot of one where we're seeing a transition in ENSNO, which is the basically El Nino and La Nina. And let me show you what I mean by that. Let's see, where's that data? Here we are. Okay, so we have our La Nina state here. Okay, we're still in a La Nina state. But we're starting to see some changes. And the changes, let me pull up this data here, shows up in the subsurface. So we've been seeing this sustained environment around Nino 4 is the coldest region. But overall, remember what I said last week about that spike? Well, it pretty much played itself out, which is pretty much clear indication of a Kelvin wave influence. But what really stood out to me were two things. One, the subsurface is starting to moderate again. And you can see that very nicely here, where you're seeing a focus pretty much around Nino 4 starting to collapse. Around Nino 2 and 3, it hasn't really pushed any further, any closer to the surface. It's pretty much stopped. And you're starting to see a little bit more of an expansion of the warmer conditions here at the subsurface, but not building up towards the surface. So what this tells me is that we're seeing a lot of indications for more of a neutral environment taking place here, probably by about December, based on the way that the subsurface is evolving here. But more importantly is the signals we're starting to see from the SOI. The SOI, as I've been explaining for some time, is an excellent measure of the atmospheric response to La Nina or El Nino. And in this case, what you want to focus on are the monthly and seasonal 30 and 90 day anomalies. And if you've been watching them for several months, from the midsummer, let's say mid-July, to now, you're seeing a steady and slow decline in these values. This means that La Nina will not crash and disappear. It's going to gradually go away, slowly. And when you have a slow transition, combined with a lot of other volatile interactions like the increase of water vapor via the volcanic eruptions and the well below normal sea ice in the Arctic, you combine those factors, and what you end up with is this environment here. What do you think I'm pointing out? What do you guys think I'm looking at? That's a subtropical jet stream. Why is that important? In a strong or moderate La Nina, the polar jet stream is king. It dominates everything. It can march across the Pacific and drive a Pacific air mass right across the United States, making snow lovers cry everywhere. It has the potential of driving Arctic air masses into the northern plains, but because of the intense trough that develops in the plains, you get our dreaded southeast ridge and storm tracks towards the eastern Great Lakes. A strong La Nina means that you can't get your high latitude blocking to really line up because the jet stream's moving too fast. The polar jet stream. Now, in a strong El Nino, it's the subtropical jet stream that is too strong. It's powerful. It's driving shortwave after shortwave into the southwest. It's leading to widespread heavy rainfall and mudslides into California. And of course, California thinks the world's ending as a result. It's leading to major severe outbreaks in the southeast because you're having strong shortwaves march across. And it prevents the polar jet stream from digging, which means your cold air gets bottled up over the north. And that means your high latitude blocking really doesn't have a chance to develop. And the subtropical jet stream overrides and overwhelms everything. And you end up with the annoying development of storms developing too far out in the Atlantic and the northeast and the northern mid-Atlantic getting rain and then a cold, blustery day. And memories of snow flurries. But when you have weakening states of each of these, you end up with an environment where the polar jet stream is strong, the subtropical jet stream is strong, but neither one overwhelms the other. And so what you start to get is more interactions between these two jet streams, a more what we call phasing. And if that phasing works out just right, it can enhance high latitude blocking. And if the high latitude blocking develops just right, well, you get a lot of happy snow lovers or very, very ticked off parents trying to deal with the snow days or lack of snow days. I don't know what they do these days, but you get the point. So what I am seeing here is a more active subtropical jet stream in a weakening La Nina environment. A lot more moisture involved here. And already with this disturbance here, we're already seeing, and I'll pull up this 500 millibar vertical velocity. We're already seeing more interaction between these polar short waves and these subtropical short waves. Very faint, very, very minor, but it's a signal that I am keeping a very careful eye on. Because if they interact just right, late fall and winter can be rather stormy around here. So I'm keeping an eye on that and how that evolves. But in the meantime, that interaction at the very least means that we have more moisture transport in our weather, in our storms, and a higher potential for the type of rainfall events that we just seen just 24 hours ago, or really 12 hours ago. And so we're seeing that interaction taking place here. We're seeing, because of that interaction, you're seeing these troughs and upper level lows bend more to the southeast here, more of a lag, and more of a moisture transport. And take a look at your temperature transport here. More interaction of polar air masses involved in this weather pattern. So, very interesting evolution all taking place. And that, of course, leads to weather patterns where, again, the weekend's beautiful, but then we get these periods of prolonged shower threats and perhaps a day or two of moderate to heavy rainfall, which is essentially what we need, this type of weather pattern, in order to break our drought. So that's everything I have for tonight. I'm going to take your questions now after I drink this coffee. But these are all the things that I've been thinking about that I want to share with you. So let's go over first the premium chat, and then I will check out a very active YouTube chat. Very interesting. So we will get to all your questions, and we'll do it right now. And by the way, the Mets are winning 7-0, which means they're going to be taking over first place once again. So all the doom and gloom could chill out. All right, so let's see here. Good evening, Card. Nice soaking rain yesterday. Nothing too heavy, but mostly steady, light to moderate rain. Really soaked into the ground really well. It's great to hear. And no horn. That's good to hear, too. Split updates are working well. Oh, he was at the Rammstein show last night. That had to be fun. Are they looking at the water vapor above the stratosphere since it got all the way to the mesosphere? All right. I am looking at the mesosphere, but it typically does not have... The mesosphere and what involves in the mesosphere does not typically have an influence on what's happening in the troposphere. It's kind of a couple layers too far removed. It's interesting in terms of the ozone production in the upper stratosphere, and it's a factor to study in terms of satellite, getting satellites up there and the interruption they're having. If you're noticing anything funky going on with your iPhone, cell phones, satellite TV, internet in general, that's part of that factor, actually, the transmission. So it's kind of screwing around with that. Indian Ocean looks like it really cooled off some more. Yeah, it totally did. Let's see here. It really has cooled off quite a bit. Very nicely done. And again, that's another signal that is weakening our La Nina support. Doesn't the heat transport from storms intensify due to the warm western Atlantic from the negative AMO help enhance heat transport to the polar regions? Most times, you have to have the favorable QBO state to really enhance that. And you also have to have an alignment with the polar vortex to support that transport. Sometimes that transport gets shut down because the upper level winds go from west to east rather than from southwest to northeast. So it kind of depends on how that evolution takes place. But it certainly can. It certainly can. In this scenario, what's really wild is that these water temperatures are well above normal. Pick for whatever reason why, they're well above normal, okay? So you basically have what I would call nitroglycerin in the form of storm potential here, sitting off the east coast up towards the Canadian Maritimes. That could lead to very powerful storms for the coastal waters of the eastern United States, from North Carolina all the way up into Maine and the Canadian Maritimes. So there's a lot of uncertainty and wild card there. There is essentially warm water throughout much of the northern Pacific and northern Atlantic, and you're not getting a true negative PDO signal and your positive, or should I say your negative AMO signal is a little bit muted because the warm water is getting into those environments that typically you would see below normal anomalies. So it's kind of a mixed signal. So it's kind of difficult. Typically with a negative AMO, you get cold water here wrapping all the way around, kind of like a horseshoe. But that horseshoe is broken up by all this warm water here. Now, when you get warm water up here, typically that means a negative NAO pattern is going to develop. But that usually leads to below normal water here, which we're not seeing because it's well above normal. So, as a result, do you go by just the anomalies or do you go by the thermal gradient? Which then leads to the question of, if the anomalies aren't important but the thermal gradient is, where does that thermal gradient set up and evolve for November, December, and January, and how does that lead to a feedback? And what I mean by gradient is this right here. See that thermal gradient that sets up here? You got your Gulf Stream, and then you get this really tight thermal gradient that sets up. If that is the driver for cyclogenesis and the negative NAO pattern, then game on. But is this signal so overwhelmed by such a warm environment that everything gets pushed further north, which would then lead to a positive North Atlantic oscillation? In other words, instead of the upper level low setting up here, it sets up here, which displaces the ridge up here, and you end up with essentially a pseudo positive to neutral NAO environment. I'm not sure yet. So that's where we are with that. If CO2 emissions were such an emergent threat matter, why are the same people saying that it also leading the charge to shut down nuclear power plants and preventing new ones from being built when they provide massive amounts of CO2 free emission? Hey, look, I've been talking about nuclear energy for a long time. Don't get... How do I put this? In terms of my statements, I take the politics out. I don't understand politicians. That's why I would never run for office, because they drive me insane. What I'm just telling you is the science. Introducing CO2 warms an environment. It's pretty case closed in that environment. It's a greenhouse gas. I would solve the solution by going nuclear. That's where I stand. I can't fix the world, guys. I could just give you my opinion. No one wants me running the entire world. I wouldn't want to do the job anyway, unless I got a lot of free peanut butter. That might be a deal breaker. A lot of free peanut butter. Yeah, well. Let's see. It's a recent piece out that hits the effort to fundamentally transform energy use within less than 15 years. Yep, I have read that. Was the widespread rainfall enough to eliminate the dry boundary layer? That's a great question, James. It's definitely dented it. We're moving into an environment now where convective precipitation is not that important. So that factor is going to become less and less of an issue, but we're still going to be dealing with Virga at the start of storms. But I think this first rainfall event put a nice dent in it, but we need more of them to really establish an improved environment. When was the last day that we had widespread high temperatures in the 70s in New Jersey? Early May, I think? Maybe April? It's been a while. Depending on species, fishermen look for those thermal gradients because of a lot of fish, such as bluefin, tend to gather in those gradients. I agree 100%. It's a very, very important indication. Now we're going to check out YouTube. Good evening, Judy, Mark. We need a tropical storm. No, we don't. We don't want tropical storms. Rainfall, sure. We don't need the wind. How much rain will it take to put a dent in the drought? This is certainly a good start. We need several weeks of what we just saw every week to erase the influences that we had in the summer. So eventually we need a wet fall. The massive rainfall event and floods around the world have been wild. Every degree Celsius of global warming means the atmosphere holds 7% more water. Yes, to an extent. This is why I've always focused on the precipitable water value and not the temperatures. Temperatures are always subjective. You have a lot of error analysis, but precipitable water value is a very, very concrete and a stable equation that you could use. And you could also take previous data and extrapolate that, and it's very stable. And so I always discuss these issues in terms of precipitable water value, because really the more water you have, the stronger the storm you can get. El Nino is predicted to return in 2023. Maybe. Seen some mild guidance on that. We'll see. I mean, it certainly would match the evolution, but I have no idea what the strength would be, orientation, or anything of that nature. Or if it would be a very weak El Nino. Does the lower amount of ozone have any effect on sea ice? And if so, how does it affect it? Not really. Okay, so the lower ozone amount typically leads to a colder stratosphere, which typically would support initially a more robust polar vortex. At least the environment would support that. But the lack or the severe reduction of sea ice at the lower levels, at the boundary layers, enhances thermal gradients, enhances storms, which enhances upward motion in the atmosphere, which interrupts and weakens the circulation of the polar vortex. So you have two conflicting factors there, which can lead to a lot of uncertainty in how the evolution will take place. Earth was closer to the sun back then. The sunlight was still stronger. The Earth wasn't that much. It wasn't like it was significantly closer. The axis was a little bit different, but the actual location was still within the Goldilocks. In fact, there was very little in terms of the position of the sun in relation to the distance of the Earth. The difference was the actual axis of the Earth was a little bit more upright, but not by much. But only a little. You only need a little bit to make a difference. Let's see here. Hello from Connecticut. Hey, Max from Connecticut. Good evening. Good evening, Steve. This is from Elisa Awazali. I apologize if I mess up your name. Trust me, I get everyone's name wrong.
Bad with names.
Very, very bad with names. Good evening, Steve. I was wondering what you think of the PDO state, because it looks like the sea surface temperatures have risen around Alaska and over the northwest coast. I would call this PDO state, and again, let me zoom in here. The best description I would call this PDO state is neutral. It's not positive, because if it was positive, you'd get cold water here. It's not negative, because if it was negative, you get cold water here. Really, you have no significant areas of cold water whatsoever. So what I would call this is a neutral warm state. Unique, interesting. This pocket right here will enhance any tropical system that marches up towards the Aleutian Islands, which could be problems. And this state right here that we're seeing would basically continue to support the upper level lows that keep on developing right in this area here. Now, we're not dealing with a true negative EPO nor a true positive EPO pattern here. When you have an upper level trough here, it's basically kind of a pseudo environment in which we have to watch and see what the wavelength, orientation, and amplification is. Because what you have set up is this trough set up here, a ridge set up as a result here, and a deep trough here, but it tends to be a positively tilted trough. So that's what we're going to have to watch out here. If this trough digs more towards the Gulf of Alaska in the winter, then this positive tilted trough is going to be setting up over the Atlantic Ocean. Like right around here is the trough axis. If it sets up around here, then, well, game on for cold air and a lot of mischief. You're welcome, Judy. When the sun returns to poles in October 2022, December 2022, in the winter pattern cycle begins stirring up.
Weather pattern cycles.
When the sun returns to the pole. Oh, I see what you're saying. Okay. It starts to, we're starting to see the development of the polar vortex right now, in fact. Actually, last week it started to crop up. I don't know why. I had a difficult time reading that question. It must be because I need more sleep. Yeah, that's probably why. So that is some excellent questions. It's already 8:50. How did that happen? Wow. And the Mets are up 8-0. That's good. See, all of that doom and gloom for the Mets, they're fine. So let's see. We've had a very active night. We had a lot of information to share. So if you have more questions, throw them out here, and I will be happy to answer them. And in the meantime, we'll check out and see the radar here and see what's evolving. And let me take out the infrared satellite and let me zoom in here. So you can see here with our low pressure system off the coast here, precipitation still rotating in. We're starting to lose that influence here. We're starting to dry out. But I wanted to show you this right here. As this low pressure system, in fact here, let me use the water vapor satellite picture. As this trough pushes off the coast, it's going to start to interact with our hurricane here. Hurricane Earl. And as this starts to evolve, what you're going to see is something very interesting. In that it's going to start to pull it into this trough. And don't be surprised if we get a very powerful subtropical storm, Earl, right here. An expansive storm with a warm core center with significant storm impacts from the coastal waters of the Canadian Maritimes down through New England and out towards the Atlantic. And don't be surprised this weekend if you get warnings about very strong swells and what's it called, riptides on the Jersey Shore and Long Island and southern New England. I think this storm, it's forecast to become a major hurricane, but I think it's going to become one of those rare super storm events that you see in the Atlantic sometimes with a perfect interaction evolution. So that's what I see happening here with this storm environment. Very interesting stuff taking place. So it won't be a direct impact on us, but it's going to be a great learning environment and learning tool to see how these features interact and work together. Surfers in the Northeast are going to love it if it happens. Oh yeah, they definitely will. But I would hopefully that they use some extreme caution when they go out there, because it is going to be rough. That is for sure. Well, I think we took all the questions for tonight. I hope that you guys got a pretty good idea on terms of climate and what I was thinking and everything else. You know, the season's going to start to get more active. And oh, by the way, I got new shirts out. By the way, a new swag coming out. I'll post it on the website once it gets here, because I want to kind of wear it first and check it out first. But you could definitely go and purchase it if you go to the public discussions. There's a link in there. But new stuff coming out with the logo right in the middle, so definitely check that out. And that's it for tonight. I will see you next week at this time. Thank you as always. We got a couple questions. Wait a minute. With Nina going towards neutral, does that lead to early cold and snow, or wait until after Christmas and New Year? Don't know the answer to that, Brian, just yet. That's the honest truth. I know that you see a lot of winter forecasts out there, a lot of stuff going on, but there are a lot of unknowns I'm still working out first before I can answer or even come anywhere near close. But of course, in October, I will be issuing my winter forecast with details like what you just asked. But I know you probably want an answer, but the honest truth is that I don't know yet. Well, as always, have a wonderful evening and stay safe out there. And I'll see you next week. Same time, same place.